Hi, good day. Welcome back to our webinar sessions on artificial colors replacement. Today we will learn about some particular challenges and opportunities related to the replacement of artificial colors in the confectionery industry. During today's session, we will start by addressing two of the most common myths on the suitability of natural colors to replace artificial ones in confections. Then we will see some examples on how natural colors can be used successfully to either match or become alternatives to artificial colors. And finally, we will finish with some technical tips and tricks to make a smooth conversion to naturally derived colors. So, you probably have heard or even believe in these two myths about naturally sourced colors: that they don't have enough vibrancy and that they are not stable enough to replace artificial colors. Well, let's talk about this. We measure and describe colors through the use of an instrument called colorimeter. Colorimeters quantify the light that comes out of an object and allows for color comparisons, providing parameters such as the hue, which is the color identity. It defines how green versus red and how blue versus yellow a sample is. The lightness. It tells us how light versus dark a sample is, having black on one extreme versus a specular white on the other. And chroma, that tells us how saturated or intense the color is. And the latter two factors are exactly an objective way to describe vibrancy or vividness, that is, brightness and intensity. The samples shown at the bottom of the screen are colored with artificial pigments, and the top ones use natural alternatives, and as you can appreciate, they look very similar. Chroma and lightness values between them are very close, which tells us that we have a good match not only on hue, but on vibrancy. Furthermore, there are things we can do to improve vibrancy. One of the technical strategies that helps is using the whitest or the lightest possible base. Like in this case, where we have candies that have been panned either over chocolate centers or pre-coated with a white layer. The brown undercolor not only affects the hue, but it also absorbs a lot of light. White bases, on the contrary, effectively reflect the light, increasing vibrancy and permitting clean and sharp colors. And here we have a last example on vibrancy. Something peculiar we notice in some artificial colors is that they seem to glow. Well, that is due to their fluorescence. Fluorescence is the property of some molecules that absorb invisible UV light and reflect the energy back as visible light. UV excites electrons that change their energy level and then release that extra energy in the form of light of a lower wavelength. But this property is not exclusive to man-made colors. Many natural pigments also show fluorescence, as can be confirmed when seeing the colors under black light, like a near UV torch. We see curcumin glowing green, carminic acid that is normally orange looks red blood, spirulina and galderia shine pink, and anthocyanins have a purple glow. But these glowing colors are not only visible under black light. Remember that the sun and artificial sources of light also have ultraviolet light. The colored light that is emitted due to fluorescence adds up to the reflected light, increasing vibrancy and giving out glowing effects. So yes, we can have intense vibrancy using natural colors. Myth busted. Another common myth is that natural colors are not stable enough in applications and are not a good match to replace artificial options. Yes, we have challenges. High processing temperatures, poor cooling rates, a variety of formulations that contain acids, occasional light exposure. Well, these seem all complex hurdles for the technical success of naturally sourced pigments. But we should take that premise with a grain of salt. In fact, candies and sweets have advantages that help to protect the chromophores, meaning the molecules or the part of the molecules that are responsible for color. First, many types of candies have a low water activity. Lower water activities limit the extent of fading. We also have high viscosities that, in the case of using color emulsions or suspensions, prevent potential defects like ringing, creaming, or precipitation, something that could happen in less viscous applications like some beverages. Fruit-flavored candies are acidic in nature, which favors colors like anthocyanins. Their intensity and stability are increased at lower pH levels, and we know that reds are among the most popular colors in candies. Other natural colors are less stable in acidic environments, but we will always have options for most of the hues. And anyway, we have formulations as well as processing strategies to work even with the least stable ones. On the other side, there are confections with a much milder pH, like gummies made with agar-agar or carrageenan, or some non-fruity chewable candies. And finally, many candies are wrapped and sold in opaque packaging, or have external printed packaging, or both, wrappers and outer bags. Certainly, there are packaging with little plastic windows that expose the sweets, but we can always choose one of the multiple light stable colors available or compromise with a more protective packaging format. We have here side by side some gummies colored with combinations of US approved FG and C colors and their corresponding natural color substitutes. For strawberry, cherry, orange and peach colors, we used varying ratios of beige bright black carrot juice and our natural beta-carotene emulsion M-Seal. Pineapple yellow was obtained with turmeric, and the apple green was achieved with a blend of spirulina and turmeric. The samples were subjected to an accelerated stability test, exposing them to the equivalent of 12 months of supermarket lining conditions. We can see that we obtained very good results for most of the colors, up to 9 months, and some of them resisted the whole year. The peach and lemon samples were the least stable, but we can note that tartrazine or FG and C yellow number 5 also faded with time. We were able not only to get precise matches of artificial color blends with natural colors, but we achieved the required stability, even in these very challenging testing conditions of direct illumination. Which means that in a more realistic setting using commercial packaging, the results will be even better. Strategies that can help with light stability include opting for opaque or semi-opaque packaging if possible. Cloudiness of the base helps to prolong color intensity and stability due to light scattering effects. If you are aiming for the shade of FG and C yellow number 5 or its blends, you can consider alternative options like beta-carotene emulsions or safflower concentrate that is not permitted in the US but can be used in other regions. The addition of a small amount of ascorbic acid to the candy formula greatly improves the light stability of carotenoids like beta-carotene and paprika. And precisely, we can see here some yellow color examples applied in gelatin gummies that were either stored in the dark at the left or exposed to diffuse interior light for 3 months at the right. We have safflower concentrate at the top, followed by M-seal beta-carotene with the addition of ascorbic acid. Below it, we can see the poor-like stability of water-soluble curcumin or turmeric. Interestingly, the lower set of gummies shows our Microma curcumin, a micronized turmeric format that shows improved light stability when compared to regular curcumin formulations. The chart presented at the right side of the slide shows the evolution of the B-value plotted against time. The B-value is the colorimetric coordinate that measures the yellowness of a color in the LAB color space. Microma curcumin keeps its yellow character for a much longer time, and therefore is a good option for the replacement of yellow number 5 in candies and sweets that are sold in semi-transparent packaging. With light stability covered, we can also question heat stability. And we have excellent news. There are plenty of options of natural colors with a very good heat stability. We have here examples of naturally colored syrups of glucose and sucrose that were exposed to 85 degrees Celsius or 185 Fahrenheit for 2 hours. This is a type of syrup that will be used in gummies manufacturing. The colors displayed outstanding heat stability as demonstrated by the visual aspect and the very small delta E values calculated. Delta E is a measure of how different two colors are, and in general we can say that consumers won't find a significant difference between two samples with a delta E lower than 3. Alas, we have challenged our myths on natural colors not being as good as artificials in confections manufacturing. And now, here we have some examples of what we can do with natural colors to match or to replace artificial colors in confections. Let's start with pink colors. Red number 3 or erythrocene is an artificial pink color that is not widely used in the global market, but there is a special interest to replace it because of its recent ban in the US, where it was used in certain types of popular seasonal confections. Good alternatives to get this pink hue are some anthocyanins from vegetable sources like purple sweet potato or red cabbage. This must be used in an acidified base to get the desired hue and the best stability. Carmine also provides a close shade to red number 3, and it can be used in a wider pH range to anthocyanins, but it is not apt for vegetarian diets nor kosher certifiable. Beetroot red is not the ideal option for thermally treated foods because of its heat sensitivity. Our Endure red beet extract that is designed to have a better heat stability could be tried in candies with limited heat exposure and very low water activity. Its stability during shelf life must be carefully assessed as well. Instead, beetroot can be used in processes with milder temperatures like pan candies. For compound coatings, our Microma line of pigments allow for bright and intense pinks from sources like beet or carmine. To replace Allura red or FG&C red number 40, in water-based applications, we can opt for anthocyanin sources with a neutral red cast, like Amaze Orange Red or deodorized red radish. Carmine blends with carminic acid are also great matches with excellent light and heat stability. Custom blends of reds and a source of orange or yellow allow for a more precise hue adjustment and performance optimization. For instance, the pink cast of beetroot can be neutralized with a small amount of annatto extract to get a vibrant neutral red in pan candies. We also have micronized colors for fat-based applications like Microma Berry Red. Now let's see orange colors. Sunset Yellow of FG&C Yellow number 6, despite its name, is often used to get bright orange colors. The result may vary according to the rate of use and the base recipe, from a deep orange to a creamy peach color. Carotenoid emulsions like Emsil Paprika are great natural alternatives for this color. The emulsion's particle size affects the hue from a slightly reddish to almost honey-like orange. The bright orange carrot is a carrot juice concentrate, which represents a friendly label option in applications that don't contain fat. Custom blends of red and yellow colors also allow for orange profiles. And then we have the expensive and non-kosher but vibrant and very stable carminic acid. In addition, oftentimes you'll be interested in matching a blend of yellow number 6 and yellow number 5 to get a flavor profile like Valencia orange, peach, or mango. That is also possible with the orange hue provided by annatto extract, beta-carotene emulsions, or custom blends. For oil-based applications, we can use native oil-soluble carotenoids like paprika oleoresin and bixin, or micronized water-soluble pigments like Microma annatto that is norbixin-based. Now we will see some bright yellow colors. Tartrazine or FG&C Yellow number 5 is used widely to get bright yellow colors for profiles like lemon or pineapple. Turmeric or curcumin provides the closest color match with vibrant results and excellent heat stability, but protection from light is required, as we saw previously. Safflower and lutein are stable alternatives that can be used in some target markets like Europe or parts of Asia. Beta-carotene emulsions are slightly warmer in shade, but some of the formulas with a smaller particle size get very close to the target hue. They have good stability and are generally approved worldwide. We mentioned earlier that Microma curcumin is a more light stable option compared to regular turmeric formulas. It will shine in pan-coated candies and compound coatings because its micronization process is translated into a large surface area that reflects more light, creating a robust color expression and great vibrancy. And now we have greens. Of all the possible green shades achievable, we selected a blend of yellow number 5 and blue number 1 with the characteristic lime profile. We can get a variety of options from the combinations of natural sources of blue and yellow and with our current offerings of green blends. Spirulina combined with turmeric is a superb match that we offer under the name Ultimate Green Blend. Where safflower is permitted, its blends with spirulina can provide label-friendly and light-stable options for vibrant greens, like in our lime green blends. Our Verifill, copper chlorophyllin, and chlorophyll, which are permitted in Europe, Asia, and JECFA-compliant countries among others, give a more naturalistic shade of green, appropriate for herbal flavors like mint or basil. When butterfly pea is used as a source of blue in neutral pH applications, the resulting green has a slightly brown underhue, like roasted pistachios. For acidic applications, Galdiria blue extract can be used instead of spirulina to get green blends, something that will simplify the process and offer great color consistency. And here comes a popular color in confections, blue. To replace brilliant blue or FG&C blue number 1, we have the following considerations. The use of spirulina in hard-boiled candies and fruit juice can be challenging due to limited stability to heat and acids. Overdosing and adding the color during the cooling stage and before the acids can help to maintain vibrancy. Everzure Garderia Blue Extract, on the other side, has excellent acid stability. Since heat is still a limiting factor, it is advised to add it while the candy mass is cooling. On the other hand, Gardenia and Genipa Blues are heat and acid stable, but the hue is a deeper indigo blue. For compound coatings, we count with Microma Spirulina that gives a color range from Pacific Blue to Aquamarine, and we also have Microma Blue Cabbage that delivers a hydrangea shade of blue. Let's continue now with purples. As a reference for an artificial purple color, we chose two blends, one made with FG&C Red 40 and Blue 1, and another with Red 3 and Blue 1. These blends are common combinations in the USA for profiles like grape, blueberry, or fantasy colors. A micronized form of carmine that has a bluish cast called Microma Blue Carmine delivers a very authentic purple color. Combinations of beetroot and spirulina, like our lavender purple, are perfectly reminiscent of floral purples. Beetroot red can also be combined with butterfly pea extract or with Everzure Garderia in different ratios to get an even more varied gamut for berry flavors. We have ample variety of references of Microma purples and violets that really shine, and their versatility multiplies when playing with different usage ratios. And finally, we have brown colors. It is quite common to formulate bespoke brown colors with the combination of red, yellow, and blue artificial colors. The diverse options of caramel colors can suit the needs for any brown profile, like peanut, chocolate, coffee, or cinnamon. For consumer-friendly labels, you can opt for our Nature Brown Apple, Nature Brown Malt, and burnt or caramelized sugars, where these are permitted. Let's summarize now some of the things we learned to maximize success in artificial colors replacement for confectionery goods. Color matching is an art and a science, where both visual cues and colorimetric measurements are important to choose the colors or blends that we need to replace an artificial color. We also should avoid generic replacements because, in many cases, we won't have proportional scalability if we address different usage rates of an artificial color. For example, Sunset Yellow or FG&C Yellow number 6 can be amber or deep orange depending on the usage rate. Therefore, we will have to opt for different natural sources like annatto extract or paprika respectively to match these two different targets. For unparalleled vibrancy, you can use one of the many natural colors with fluorescent properties like beetroot, spirulina, turmeric, or anthocyanins. Also, the rate of use may need some adjustment because that influences chroma, that is a measure of intensity. We also have to consider the point of addition of a color, that can affect solubilization and full color expression, like when we deal with acid-sensitive colors like spirulina. Also, remember that bases or matrices of lighter color, like white or beige, allow for cleaner and sharper results when adding colors. For best performance, our color scientists will use stability criteria to choose the most suitable option for your product and process, addressing the usage rate so that the color can withstand processing conditions and shelf life. They will also work with you to ensure flexibility so that you can use your new natural alternatives in future projects. Thank you for joining this webinar session on artificial colors replacement for the confectionery industry. If you have any technical or commercial inquiries about our product portfolio and capabilities, please reach out to us through the contact section in our webpage. Goodbye.